Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Mend and AWS. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead, but before we get things rolling, I do have just a couple of housekeeping notes to review. First of all, we are recording today's session, so if you happen to miss any of our discussion, if you'd like to rewatch at a later point in time, or if you'd like to share with your team, you will be receiving an email with a link to access the recording on demand. If you'd like to engage with us, there are a couple of ways to do so. The first option and the easiest option is the chat tab. You'll find that chat feature on the right side of your screen, and as soon as you find it, I want you to let us know from where in the world you are joining us. If you have any specific questions, we do want you to send your questions to that Q&A tab on the right side of the chat section. We'll be holding all of our questions until the end, so you've got the whole time to send in your questions. So be sure to send them in as soon as you have them. If you jump over to that handout section, you'll see there are a couple of resources as well as the slides available for download. So feel free to grab those to follow along. And before we close things out today, I will be giving away two $25 Amazon gift cards. So be sure to stick around to see if you're one of our lucky winners today. So our topic is securing cloud-native applications across the software development lifecycle. And I'm joined today by Omar Dahan, product owner of cloud-native security at Mend.io, and Faisal PS, senior partner solutions architect at AWS. So Omar and Faisal, thank you both so much for joining us today on Techstrong Learning. Omar, I'm going to pass the mic on over to you to get us started.
Perfect. Thank you, Cody. Thank you so much. And hello, everyone. Good evening, good morning, good afternoon, whenever you are joining us. So today we are going to cover the securing cloud-native application across the development lifecycle. Really short. I think that Faisal and I will introduce ourselves a bit more. So Faisal, please go ahead, and then I will take it from there.
Sure. Hello, everyone. So my name is Faisal Pias. I'm a senior partner solutions architect at AWS. I work primarily with our ISV partners focused on network and security solutions. So I work with our partners to build solutions that our joint customers can use. And today I'm very excited to be here with Omar, one of the partners that I support at Mend.
Perfect. Thank you very much. So I am Omer. I am the product owner and functioning as a product manager at Mend for the cloud native solution that we offer. Previously to Mend, I have some development experience and also some business experience that is related to the DevOps world. So I'm really enthusiastic about basically like software development and technologies in general. And what we're going to cover today is, first of all, Faisal will start with covering the AWS approach for cloud-native application, why it matters. We will cover some of the AWS approaches, the benefits of cloud-native applications, and some services that AWS provides. And later, we will go into the application security part for the cloud-native applications. We will follow the development lifecycle. We will see different ways to look at it from a security perspective, obviously. We will see what is important when you secure your applications, but more important is how to manage your risk around cloud-native applications. And let's enjoy the time we have. So Faisal, you're good to go.
All right. Thanks, Omar. Okay, so we start with a quick overview of what is cloud native, and I'll cover mainly the AWS perspective of it. So cloud native is an evolving term. With all the software that is being built, it needs a place to run, and you can also think about how the pieces fit together and cohesively work as a system. The CNCF definition states cloud-native technologies empower organizations to build and run scalable applications in modern dynamic environments such as the public, private, and hybrid clouds. This definition has to broadly apply to everyone, and not everyone has the same capabilities. So we call this the lowest common denominator problem. This is where you try and appeal to a broader group and their capabilities, but in doing so, you need to limit those capabilities that can be leveraged. At AWS, we go many steps further and have a broad set of capabilities in a family we call serverless. Serverless technologies is more than just AWS Lambda, if you're familiar with the service. And serverless services remove the heavy lifting associated with the running, managing, and maintaining servers. This lets you focus on core business logic and also quickly add value. At an organization, we have gone through and addressed the different problems that other organizations have or will have at scale. And the services that you see in the AWS product catalog and our partners catalog is a direct reflection of that. As an example, the AWS SDKs have features in it such as retries, exponential backoff, circuit breakers, and jitter. What this means for you is that you don't have to think about dealing with lower level issues such as transient failures or back pressure, and the SDK handles this logic for you in a manner that scales really well and doesn't cause additional cascading downstream problems. For other examples of services that remove the heavy lifting of managing and maintaining services are EKS for managed Kubernetes, EventBridge for a managed event bus, SNS for managed PubSub system, SQS for queue, Kinesis for streaming, and so on. Now, let's take a quick look at the shared responsibility model at AWS. The AWS shared responsibility model makes it easy to understand your choices for protecting your unique AWS environment. And it provides you with access to resources that can help you implement end-to-end security quickly and easily. AWS provides security off the cloud, which means it protects the hardware, software, networking, and facilities that run your selected AWS cloud services. And you, as a customer, control the security in the cloud, which includes updating and patching the guest operating system, associated application software, and configuration of the AWS provided security group firewall. These are just examples. The responsibility metric may vary depending on which AWS service you are using and whether or not it is a managed service. The AWS Partner Network offers access to a large number of partners who can help you fulfill your security responsibilities through solutions and consulting services. The shared responsibility model empowers you with the clarity, flexibility, and control you need to build on the cloud with the utmost confidence. So next, let's talk a little bit about modern applications. So businesses want to deliver business value faster and stay competitive in the market. Modern applications center around separating and decoupling the monolith into smaller functional services or microservices that focus on one thing and do it really well. Each microservice often has its own data store and can be deployed and scaled independently. They represent the real world where service boundaries equals business boundaries. This also leads to an evolution of the teams by giving them the autonomy to architect, develop, deploy, and maintain each microservice. Finally, you end up with the ability to make decisions really quickly because decisions only impact individual services. Cloud-native microservices then take advantage of the cloud for elasticity, platform, and software services. After all, innovation requires change. You can learn faster by making lots of little changes to drive incremental innovation rather than waiting to take one giant leap. So why is AppSec important in cloud-native application development? As organizations evolve to a more distributed ownership model, one of the key metrics is speed of features reaching the hands of customers. However, we still want to make sure that the security bar is maintained and ideally raised over time. Empowering builders to make better decisions earlier in the cycle reduces cost of delivery and increases the quality of the delivered software. Integrating security through training, ownership, tooling, and well-communicated feedback loops results in raising the security bar for builders and the whole organization. Better decisions earlier also means that when teams get to the security review stage, the humans in the process spend more time on high-value activities. The other benefit of an effective AppSec program is that you can use the data from the security reviews to prioritize the next more important actions, automation, or standard across the whole organization. Sometimes this approach is referred to as shifting left. Now we'll take a quick look at some of the AWS security, identity, and compliance solutions. At AWS, we align our security services to the key areas defined in the security pillar of the well-architected framework. These key areas are identity and access management, AppSec, detective controls, infrastructure protection, data protection, and incident response. These security services are purpose-built to rapidly address the AWS customers' business and technical use cases, and also help organizations to develop and evolve security, identity, and compliance into business enablers. Let's take a look at how AppSec plays a role here. Your application development methodology should include security controls as you design, build, test, deploy, and operate your workloads. While doing so, you should align the process for continuous defect reduction and minimizing technical debt. In AWS, there are a number of approaches you can use when addressing your application security program. Some of these approaches rely on technology, while others focus on the people and organizational aspects of your application security program. For example, AWS Code Pipeline is a continuous delivery service that enables you to model, visualize, and automate the steps required to release your software. You can not only integrate this with other AWS developer tool services, such as Code Commit, Code Build, Code Deploy, or Amazon ECR, but you can also integrate security services from both AWS and our partners' portfolio, such as Mend, into your code development pipeline. You can then use a vulnerability management service like Amazon Inspector to continuously scan your AWS workloads for software vulnerabilities post-deployment. If Inspector creates a finding after discovering a software vulnerability, you can view and process your findings through other AWS services, such as AWS Security Hub. That gives you a comprehensive view of your security posture in AWS. Now, let's hear from Omar on Mend's perspective into cloud-native application security.
Perfect. And thank you, Faisal, for the deep coverage of the application, the cloud-native application landscape. And basically, this is a very good basis to jump into the cloud-native application security. I will first start with just introducing Mend for those of you who don't know us. So we are an application security company that is focused on keeping your applications secure and compliant. That's basically it. We invest a lot in making security automations, and so we invest a lot in developer integrations. And we also aim to provide holistic risk management for you, because we know that for cloud-native applications, risk management is like the big thing in security. So as I mentioned, we will, what I'm going to show you next is an approach to look at the development lifecycle from a different perspective. This approach takes the the same development lifecycle that we all know and that Faisal just showed us with the same steps, looking at it from a process perspective, meaning that on the left side, we have the people and the technology. That's where people actually use technology to write the code, to build the applications, to use third-party code that others wrote and leverage it, and so on. And then we have a big chunk in the middle of the processes. That's like the biggest maybe motive of cloud native application is that we can make application development faster. We have many DevOps supporting processes to make it happen, such as like building artifacts and then testing and do continuous testing and then continuous development and then deploy and ship your application and microservices into runtime. And on the right side, obviously, we have runtime, which is the reality. This is like your actual applications that are running, and they also should be protected. But still, that's the full span of how we look at the development lifecycle. And from here, we can shift the view a little bit and looking at it as a kind of a flywheel, because that's also like one of the biggest benefits of the application, the application development lifecycle, which we get the speed of deploying and shipping applications faster, shipping code faster. So we have the people and technologies, and they drive or trigger the processes, and then we get the runtime applications, and we go on and on and on. And obviously, with every good thing in life, we have trade-offs. And we are going to cover some of the trade-offs today. But before we do it, I want to set some framing, because application security is a lot, as you all know. And thanks for Gartner for this like specific visualization of the development lifecycle. So we have many tools, we have many artifacts, we have many steps in the process that we need to cover, and it brings its complexity. And obviously it brings a lot of application security methods, such as API security and looking at and scanning custom code and third-party code. And we have open source libraries, and we have security, securing the supply chain, and securing containers and VMs and serverless functions and whatnot. And we have infrastructure as code, and obviously we have all of the runtime issues. Today, I want to be focused more on the artifact level, which is like the very basic basis of the development lifecycle. So some of it is, as you know, is the static code scanning and more of like SCA, like software composition analysis, and securing the development lifecycle, and basically talk about the risk. So let's move forward to cover the development lifecycle from a security perspective. So on one dimension, we have the software components that we care about. We have the proprietary code, and we have the third-party code, the third-party packages that we all use. And if I'm not mistaken, the right ratio between the third-party code and the proprietary code is 80% to the third-party code, to the shared code, to the open source code, and 20% only to the proprietary code. So that is why it is so important to cover those public software components. Next, obviously, we have the, let's take, for example, the Docker framework. So we have the Docker image artifacts, which we get after the building the code. We have the running containers once we deploy and making the image into a running container. And then we have the container in production with all the set of configurations and all the things that you need to have in your running application. On the second dimension, we have some security acts. So if we take like the most shifting left the most, we have the static scan, scanning your proprietary code. We have the software component analysis, which is focused on obviously on security and compliance for licensing for open source packages. And obviously we have the infrastructure as code, since it is best known for be managed through the software, the source control management. So we leverage the benefits of GitOps basically to also control our infrastructure as code scripts. That's on one side of it. The other part is the image scanning, getting a layer by layer view of what is happening in the file system of our images. We have the configurations part, which goes together to have a running container. And obviously, we have what we call as monitoring the running images. And I will share more details of it when we go into the prioritization section. But looking at production doesn't necessarily mean that you need to have workload protection, for example. If you are focused on the left side mostly, you can get things from the runtime, from the right side, and have a set of characterizations that can help you prioritize. So if you go through the process, we have the code, we have the review stage, we have the build. After we have the artifact, we push it into the registry. We do all of the testing. And then in the deployment phase, we get the image from the registry and then deploy it into production. Obviously, we also have some additional security acts as secret detection that can be done in the code section, can be done on the image scanning, and also can be done on production. And we have also, for example, we have malware detection. Just an idea of additional security acts. So now that we have the development lifecycle with a few of the dimensions of the software components that we care about and the security acts that we have, we can move to see how we want to look at security. And obviously in the development lifecycle, we have a lot of points, a lot of test points to put our security acts. For example, we can scan the code in, we can do code scanning in the repository. We can do code scanning just on specific points. Let's say, for example, we don't need to scan in every feature branch. We can also only scan in pull requests to the main branch, for example. That's one security practice. Then we have the image scanning. Right after the build, you can scan your image, get right ahead the entire file system and the findings that you have for this specific image as part of the building stage. Then you have few options. You can decide what you want to do with it. If you want to apply a quick fix, or you can push it to the registry. You can fail the build. You can block the image from being pushed to the registry. There are many security acts that you can do, and that we will cover in the next slides. So first, we look at it as we start with the visibility. We want to know what we have. That's why we have the static analysis scan. And that's why we have the SEA scan, and that's why we have the image scanning. And that is why we do also registry scanning, because it is important to make sure that we have like a holistic coverage of the development lifecycle. And so first we bring all of the data. And now basically the problem starts, because if you look at the development lifecycle and DevOps practices, each process it makes a lot of sense. It's very intuitive. You know what's the input, you know what's the output. But when you take it together as a series of processes, then you get like a compounding complexity. And in order to cover that, you need to first have visibility in the right places, and then you have a lot of data. You can do some prevention if you want to, and it depends on the security practices that you apply in your organization. But you can have, for example, proactive security prevention, meaning that if you have a certain like threshold of risk that you are willing to apply, and you have policies that should cover this, you can fail the build, for example. You can block images from being pushed to the registry, and you can also fail deployments based on those security factors. it depends on the amount of noise that you want to put on basically on your developers, because this is one of the biggest trade-offs of security. You get very fast, you can ship code very fast, but it comes with a threshold of more security acts that needs to be done, and in turn, it affects the developer experience and the developer velocity, the development velocity. So it is up to you where you set the line for the prevention. Excuse me. But this is like one practice that you can do. Then after you apply this, apply or not applying this practice, we get to the main part, which is the prioritization, because we all know that the noise is massive with security findings, and there is no way that you can develop your products in a sufficient pace and take care of all of the security findings that you have. It just doesn't. It doesn't go together, and it's not even important. And we will explain why in a few slides. And last, we need to take action based on what we want to focus on. And taking action basically is like remediation, is fixing, applying updates, removing secrets. It can be all kinds of changes, code changes that you need to take, but you need to take action. So for these are like the basic pillars for securing your application as a framework, as steps that you need to do. And now we will go into risk management and explain how risk management can help you cover those points, focusing mostly on prioritization. Up until now, we focused on the visibility and maybe the prevention on the security points where we can apply the testing. And now we will go to the first step of the risk management, which is consolidation. So up until now, we had in the security, in the application security landscape, a lot of application security testing tools. Each tool brought its own benefits, its own use cases, cover different parts of the code and different risks, sometimes to different personas. And the first step in really get good risk management is to consolidate all of those tools, security tools, security scanning tools, and combine them into one security application, one holistic application. And why we call it an holistic application? And obviously, I just mentioned like SCA and static scan and image scanning and infrastructure as code, but we can have more and more. So an holistic application allows you, we have some few major benefits. One, you have everything, all of the context is in one place. That's one. And we will go into what context really is. We have control in one place, we have scope. So imagine that you basically, you don't really care about the specific components of the source of image, if the specific finding was from an image scan or an SCA scan. It doesn't really matter. You care about your applications, and you want to know where your applications are on the center. You want to know what is the risk of the specific application. So an holistic application gives you the control and the scope. It also gives you the ability to have complex policies, meaning to combine policies and applying security acts on different scanners, from different scanners on the same application again. It allows you to have ownership of your applications, meaning that you can know the source, the code source of your application. You can know the source of the image, like the repository that is the origin of your image. And when you're talking about running application, you can also close the loop back to the source owners of the application, which is really important for the taking action part, which is closing the loop. So it allows you also tracking and obviously all of the things that you can do on top of your findings. Let's say notifications and then so on, and opening tickets, whatever you choose to handle your findings. The second step for risk management is getting the context. And again, I'm building on top of the first level, which is an holistic application. So we look at it as 3 pillars. We have the code context, we have the operating system context, and we have the runtime context. Each context provides a different level of information and a different level of a different set of capabilities to prioritize better. So for example, for code context, we have, and we all know, the CVSS score from NVD. Obviously, we have fix suggestions. We have dependencies for each root library, for example. We have reachability analysis. And all of those are aspects that provides better prioritization when you look from the code perspective. When you look from the operating system perspective, you basically add another layer to the prioritization complexity. So now the CVSS score gets a context. You have the vendor score, for example. So if you're talking about like Linux distributions, one vulnerability, one CVE can have a specific NVD CVSS score, but when applying in Ubuntu, for example, the risk can be reduced almost like to 0 just because of the way that this specific distribution and the packages and the configuration are there. We have also like fixed availability, and we have the distinction between base layer and application layers, because sometimes for base layers, we take public images and apply them. These images are basically not many companies are actually modifying these images. So you can either apply images or just decide to update them to the latest version, which is the best practice, obviously. And we have the runtime context. We can get deployment indication, meaning that we have an indication on which images are actually running. We can see which packages are being loaded. We have the additional security context. We have more and more data to prioritize better. And this leads us to the main funnel, and the main pillar of the risk management is to apply the prioritization funnel. And the claim is like that. Basically, you can see from the right, we have a lot of noise. We have a huge amount of CVEs that we need to take care of. And by applying on the left hand, each of the context or the each of the elements of the prioritization framework, you can reduce the amount of CVEs that the risks that you need to take care of. So by applying runtime and reachability, for example, you can reduce like a massive amount. Then you can apply the EPSS method, for example. For those of you who are not familiar with the EPSS method, this is an open source resource project that comes to and brings the exploitability probability of CVEs. So basically, you get in a time frame of 30 days. So meaning that you get an EPSS score between 0 to 1. It gives you the probability of a specific CVE to be exploited in the next 30 days. This is a big prioritization factor, but alone, and this is like the main goal of this slide, each factor alone is not enough. The combination between the factors is what really gives you or narrows down the risk pool that you need to take care of. Obviously, we have the CVSS score with the OS operating system context and the fixed availability. The reason that we do all of that is because by the end of the day, we need to tell developers what to do. They need to be able to actually apply the fix. So if we don't have any fix available, basically there's nothing we can do. And then we need to give them the minimum amount that is really important for them to be or not to be frustrated. And the last step basically is to close the loop. So this is kind of a reversed flywheel of the same approach that we saw for the development lifecycle. So we have the runtime and we have the runtime context. And for application security management, we have security processes that are focused on basically getting the data and have prioritization and give recommendations. And for here, we have one of the aspects, we have the OS context. And last is that remediation applies where people are actually developing. Obviously, we can do some automated remediation flows by opening, for example, pull requests, but still, there will be a software engineer, a developer that goes and see if this pull request should be merged or not. And this is also why ownership is so important, because imagine that you have an application and then you prioritize everything and you have the minimum set of CVEs that you want to fix. And now the question is, who should I send it to? So if you are lucky and you can connect your code repository all the way through and even mark the Docker file and know the source of your Docker image, then you are lucky and you can close the loop faster. But if not, I mean, I've heard not once about teams that actually manage the ownership in Excel spreadsheets. And I understand this is like a big need that is, as of today, mostly solved manually. So, perfect. So just for now, now for the fun part. So as we cover the risk management, I want to emphasize a few points in obviously a humoristic way on why you should, on why each framework is important and why you should focus on like basically day-to-day operations. So here is basically saying that everyone are really into like chasing 0 days, and it's really like this is a major risk, because once a 0 day is out, and it's really it's not enough that it is out. When it has an impact, or there is an actual cyber attack of the oh, now we're okay. So this can cause like a catastrophe in the security team, in the DevOps team, in the entire R&D department. But to cover, like, to be ready for 0 day, I think that the most you can do is have a good visibility, and with automated flows to have your security scans in the build, scanning the registries, have a regular code scans. That's the most you can do. Make sure that you cover everything, so that once a 0 day is out, you can actually quickly identify which applications are potentially at risk. But we are living in a day-to-day, which we don't really experience 0 days every day. So you need to fix your 365 days. And that's why the prioritization framework should come to your help. Second is that by applying the prioritization, you get more and more impact. So you can start by just severity, and then you have severity and CVSS, and maybe add to that the fixability of a specific package. You can add it also the EPSS. But if you also add on top of everything the reachability, which means like, is this package actually being used in the code, then you can say, I mean, you can see the reaction in the meme. Let's go. We are almost getting to the Q&A. And I want to cover more 2 quick visualizations. Thanks to Patrick Garrity, which I follow on Instagram. He is a cybersecurity researcher. He works in Nucleus. He is a great guy, and he loves doing visualizations. So I borrowed 2 of his visualizations. One is that you can see like the entire NVD database, which more than 200,000 vulnerabilities. and the way that they go into the EPSS threshold buckets. So you can see that actually a very small fraction of the CVEs actually have the probability to be exploited. And this is like a massive prioritization factor. Second is, as you can see here, we have again the total CVE database. And now there is another framework of the known exploited vulnerabilities. This is not very updated because up until today, there is around 1,000 known exploited vulnerabilities. But when you go and want to make sure that you fix the right thing, you should focus on what actually out there. And this gives you a good example of like what's the how it breaks into the non-exploited vulnerabilities. And the other thing that it is important in this visualization is to see that not only critical vulnerabilities are being exploited. I mean, most of them, as you can see, are high and critical, but there are also known exploited vulnerabilities which are medium, low, and even got the unknown score. So this is why only referring to severity might not be enough. A little bit about the main value proposition, and then we will go into covering the AWS marketplace. So we at Mend, we believe that in order to start mending your security problems, once that you need to have a consolidated security application. Second is that you need to invest in security automation across the development lifecycle. You need to invest a lot in I call it developer integrations, but what really behind it is the developer experience of your developers, because no one, and especially developers, they don't really care about security. So you need to be really laser focused when you give them, and you should give them the problems in with a recipe of how and what to do. And obviously, we invest a lot in policies and in reporting in order to also, this is another factor of securing the risk, of prioritizing the risk. Faisal, handing back to you.
All right, yeah, thanks, Omar. So I'll quickly go over AWS Marketplace and its value proposition. So why buy in AWS Marketplace? AWS Marketplace enables builders to find, buy, deploy, and manage third-party software that they need, and it encourages organizations to transform their software supply chain. By using AWS Marketplace, organizations can give agile teams access to tools and the third-party software that's needed to accelerate innovation, while it also enables procurement leaders to control software purchasing, provisioning, and budgets. And back to you, Omar.
Thank you. So, obviously, Faisal, can you mute yourself? Yeah, thank you. There's an echo for some reason. So obviously, in the AWS Marketplace, you can find Mend by looking for AWS Marketplace Mend, and there you will be able to find us basically with our products, the SCA, the static scan, also the supply chain, which I didn't cover in this webinar, and the Mend for container images, which is part of the Mend SCA offering. So please find us there. And as we reach to the end, we can have the Q&A session. So Cody, back to you, I guess.
Yeah, sure. And hey, Faisal, I just unmuted you, but we might need to make sure you mute yourself while others are talking, just in case we get that echo back. But awesome, we have received a couple of questions, and so I also want to put out one more call for anyone in the audience to send in questions of their own. But first, what do we have to consider in production and real-time scanning?
Yeah, so I'll take that. It depends. I will not. The way we look at it in Mend is that we don't really cover like production in real time. Obviously there's this separation of the shift left and shift right in the security landscape, and some of the companies, they cover the runtime, but they really lack the shifting left. And obviously there's a trade-off between the both, but we think, and I personally think, that shift left is mandatory. And I think that I'm answering like a few questions together here. So first, you need to know what you have in production, meaning that you don't need to really have like a real-time continuous production monitoring, because it aims to covering like different security aspects. You can just question your production environment and get what is running. And then you get the benefit of the shift left, because you can close the loop, you can see who is the owner of the image, you know what is the source code repository, you know who is the team in charge, and you can apply the fixes and have it prioritized because it is in production. That's the way we look at it. Obviously, you can get some factors from production, as for example, you can get like the container analysis of which images are actually loaded to the memory. There are many practices to leverage the information that you have in production. But the main thing is to actually, you can look at the entire shift left movement as a prevention method. It's cheaper, it's faster, and you know what is actually there. I hope that it answered the question.
I hope so too. If there was any kind of follow-up, participant 211, go ahead and send that in and let us know. So we just received another question. And at runtime, if malware makes it there, whatever the way it got in, is there anything that can prevent it from accessing secrets, particularly secret required to exercise the secret vault API?
Yeah. So we have a lot of runtime questions, which is great. I understand the pain. Maybe I will say again. I mean, the answer to these specific questions go into workload protection, because being active in runtime means that you need to have at least some kind of an intrusive way to look at your running containers. And this is something that obviously the biggest trade-off there is that it is very hard to implement, very hard to install agents across your clusters. But if I will try to look at it from the shift left perspective, obviously the best practice is to use a secret vault. That's the best practice anyway, everyone. I think that we'll tell you it. I think that even AWS has a service for the key storage, yes, obviously. Well, like to your specific question, this is really a matter of runtime protection, or runtime workload protection. You can get from the left side indications on malwares in advance before it is exposed into the runtime. So if you do like, as part of our SCA scan, you have like malware detection, and you can fix it while you're in the code and not in production. So that's, yeah.
Perfect. It looks here like we've got a question that pertains to, I guess, corporate buy-in, but when getting pushback from a product owner questioning security and shift left, how can you explain to them the value that shift left really has?
Okay. Just to make sure that I understand correctly. It's a prioritization question. Yeah, I understand it. I think that one way to explain it, and I'm trying to put here my like neutral product manager hat at the moment, is I would like to understand what is the risk in not in like delaying this issue. For example, you can tell me that this specific issue is critical because ABCD, it's already exploited. Other companies like experience like security breaches because of that, and so on. And to explain that the cost of waiting could be like very expensive. You can invest like a month of shutdown R&D team just because you neglected a very critical security security issue. But having said that, you need to be like very, and this is where the prioritization framework comes at hand. You need to be very focused on what you really like. What are the red flags? If I think that if you can explain the fact that you already filtered the security issues according to some prioritization framework, and you can share this prioritization framework with the product manager or the product owner, you increase your chances of getting like okay. I mean, product managers love frameworks, love prioritization, and yes, that's the language that we speak. I hope that gives you a good idea of what to do.
Right. It looks like we have another question that's specific with Mend and API. So how does Mend integrate with API development?
Okay, so API development is something like per se, we don't do API security. So we don't cover like API, like even if you scan code, we don't cover like API risk factors and security best practices. What we do is we do like the regular static scan of the code for like general risks. But that's why I gave the framing at the beginning. Application security has a lot of components in it. So there are like very big companies that are focused only on API security, as there are companies that are focused more on runtime and companies that are focused more on the shift left. And I think that also the barrier between shift left and shift right is kind of like getting blurred, because applications are applications. And that's why you can get some insights without doing the actual work in the runtime, in my perspective, to get the full picture. Yeah.
All right. And so it looks like our questions have slowed, but I have one for you that I'm curious about. So I know shift left, the whole culture that surrounds shift left is about making sure that security is a priority for everyone in the SDLC. But when it comes down to it at the end of the day, who do you think owns security for an application? Who should be the one in charge of that security?
That's a very good question. I think in a similar way that AWS looks at it, there is a shared responsibility for security. And by saying that, I mean that obviously it depends on the practices of each company and where they draw the line and what are the responsibilities of the DevOps team, or maybe they have even SecOps team separate. Sometimes it's together. Some companies have like a platform team that everyone is doing everything. And obviously there is the R&D, the actual development teams. Each company draws the line where they want, but I think that's like that's shared responsibility, obviously, because I think also that developers should care about security, because they should know that if a security breach will come up, then they are not in a good place. And yeah, so it really, that's why we try to make, I think that at the end of the day, developers really want to develop the software, to do the logic, to do the fun stuff. Security is not fun. But I think that by having automated processes and quick fixes and things that can be achieved quickly, you can get the sense of like checking the boxes. Everyone likes to check the box, and if you give them like an open pull request, and here you fix with by merging this pull request, you fix like 10 critical issues, they will do it in an instant because you gave them everything. So I think that DevOps, SecOps platform doesn't really matter, should invest heavily in automating stuff and get to know what they actually have to make the life of the developers easy. And I personally find it very like fun to automate processes and automate software processes. I run like I some days I find myself like working in GitHub and just doing like modifications on my pipeline to think of how developers are working and how DevOps are working. So that's yeah. It depends on the enthusiasm level of the teams.
Yep, of course. Well, gentlemen, we are wrapping things up, but I want to hear from Faisal as well. So I do want to give each of you the opportunity to leave our audience with any closing remarks or anything you feel they should absolutely walk away here from this webinar top of mind. Faisal, do you want to get us started there?
Sure. So first of all, I'd like to thank the audience for taking the time to join Omar and me in hearing about our perspective about securing cloud-native applications. There is definitely more to it than what we could cover today, but an effective application security program always starts with having a plan in place for the entire organization and having it well communicated to all the stakeholders who would be responsible for securing not only your software, but not only before deployment, but also after deployment. And there are AWS services as well as AWS partners services that can help you achieve those goals. Over to you, Omar.
Mm-hmm. Thank you, Faisal. Perfect. Well, I definitely talk too much. I need to rest, but I want to thank everyone that came today and listening to us. Just enjoy what you do and be happy. That's what I can tell you. Thank you so much.
Perfect. Well, Omar and Faisal, thank you both so much for joining us today on Techstrong Learning. It's been such an insight getting to hear your perspectives when it comes to shift left and securing everything. So thank you so much for your time today.
Don't forget to visit us in AWS Marketplace.
Yeah, thanks for having us.
Thank you, Cody.
Thank you. So I'd like to remind everyone that today's session was recorded. So if you'd like to rewatch this, you will be receiving an email with a link to access the recording on demand, or you can find it living on the Security Boulevard website at securityboulevard.com/webinars, and you'll find it in the on-demand section. The two winners of our $25 Amazon gift card drawing are Branka Z and Riyadh A. So to our two winners, congratulations. I'll be reaching out via email here shortly to get these gift cards distributed to you. If you don't happen to see an email from me, check your spam folder just in case it's filtered out. I'd like to thank Mind and AWS for sponsoring our program. And everyone here, thank you so much for attending. At the top of the chat is a quick link for a short survey So if you don't mind clicking that and letting us know your thoughts, we would love to hear your feedback. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, Omar and Faisal.
Thank you, Cody. Thank you, Faisal. Thanks, everyone.